Our speaker is Dr. Micah Goldwater, who is from the School of Psychology at the University of Sydney. He got his BA in linguistics from the University of Rochester over in the States in 2003, and got his PhD in psychology at the University of Texas in Austin in 2009. Was a postdoc at Northwestern University and then came to the University of Sydney in 2013. He's got a very cool research area. He's interested in the nature, acquisition, and use of knowledge, which is basically like everything. So would you please make very, very welcome in the usual time-honored fashion to talk to us a little bit about misinformation and how we can make sense of what's been going on this week, Dr. Micah Goldwater. Thank you, Micah. Welcome.
Thank you.
Sorry for completely messing up your name there.
No worries. Thanks so much for having me in the warm introductions. Great to be here. I hope this is all interesting for everybody, and please, as you've been doing the whole time, enter questions in the chat and hope to have a great discussion. All right. Yeah, so I'm talking about psychology misinformation. I'm sure you have all quite aware, as has been talked about this week, is that sometimes it seems, you see the people out there and the types of beliefs that you hear online, especially, the pandemic has really brought this to the forefront around the world, that why don't people just listen to the science, right? It seems so easy, right? It seems like an easy question just to ask, hey, we have this, here's the evidence, or all kinds of things about people's health and behavior and the choices they make. You go, hey, why don't you just listen to the science, all right? And one of the, and I think, there's actually a complicated question to that. It's not as simple as just telling people what to do and then them doing it, right? I think a lot, everyone's age group here, that people don't want to do whatever they're told all the time, right? So, one thing, so the WHO sort of coined this phrase of this infodemic, that along with the pandemic, there's also this infodemic out there of misinformation and disinformation sort of all over the world and spreading, and how this is a real problem, in this context, right? Until everyone's fully vaccinated, our behavior is entirely what determines our health in this context, right? So this really did put a lot of research, the type of research I'm doing, in the forefront on misinformation. All right, so to step back, I would step back for a sec and try to summarize all of psychology in 2 slides. All right, so what is thinking for? All right, so I'm a cognitive psychologist and I do research on how people think, okay? So what is thinking for? Well, at least all mammals, we can certainly talk about all mammals as having sort of cognition for, achieving goals in the world, right? Figuring out what actions lead to which consequences, right? So you're an animal, you have to figure out how to get food, right? And you got to figure out how to manipulate the environment to get food, right? That's a very basic goal that all of us animals have, right? And so, but of course, humans do this a bit deeper. In our ability to figure out what our actions do and the consequences of our actions, we've developed all these sort of mental capabilities to really break the whole universe up, break the world up into a series of concepts that.
You're muted.
Oh, sorry. Where we sort of break the whole world up into a bunch of concepts. And one of these concepts sort of help us do is sort of, if we sort of understand the world, we're sort of better able to act on it to achieve our goals. Okay. Now, another side effect of this is that we also, as humans, really care about explanations for things. All right. And we're always trying to generate, because one of the things about our actions and our consequences is we think about in terms of cause and effect. If we do what will happen? And when we do this, this is what happens, okay? So, and we really care about, and people just sort of naturally, because of these kinds of constraints, come up with explanations for stuff, right? And because when you come with an explanation for something, in terms of the concepts that we have, breaking the world apart into pieces that we can try to understand, we're better able to select new actions in a new situation, right? So we get to some new situation, we don't know, we see a food that we haven't seen before, we figure out what we can do. All right, so cognition, all of our thinking is sort of for that. However, we don't think alone. We don't, humans are team players generally. Our sort of greatest strength in a lot of ways cognitively is our ability to work in groups. All right. We, pictures of hunting or in creative pursuits. And so a lot of the explanations that we come up with, a lot of the ideas that we have are formed in groups as well. All right. So the ideas that we have are formed in groups. And not only that, then our groups, and in turn, get somewhat defined by the ideas and the explanations that we generate. Okay. So so for example, groups are, the explanations and beliefs and how we think cause and effect works in the world are affiliatory, in the sense that we form affiliations based on them, right? So think about a group defined by a religion, right? We're all in this group, we all share the same religion, that's all the same beliefs, right? And so the beliefs that we have as part of our group membership and part of our group identity. And so then a lot of our emotional responses to things are based on how we fit into the group, right? So think about why we all care about being cool or something like that. That's all about how your sort of social status in the group. And because our beliefs are so part of our group identity, threatening those beliefs with, say, count evidence that suggests that those beliefs are incorrect also threatens the group, okay? So I'm just going to try to that's a sort of bit of a bit of an introduction to sort of where I'm going to go. But there's a very quick sort of all of society, but also if we're thinking about these in terms of one example of how important our evolution for groups are. I'll give you one example. Humans have a unique capacity to break down alcohol, right? Other mammals can't do this, and one of the best reasons why is because it forms group bonding, okay, and things like this, right? So there are all these things that are biology in our whole. So our groupness is really important for how we have evolved. All right. Oh yeah, I just said all this stuff, right? Okay, another thing about human history here, right? Now, right, the oldest stone tool. So humans and human ancestors of humans and human-like, ancestors have been using cognition to manipulate the world to achieve our goals for, at least 3 million years, right? It's the oldest stone tools. Modern humans are around for 500,000 years. Language has been around for around 200,000 years, et cetera. And so basically we've been forming groups and collaborating in some kind of modern way for a very long time, right? The scientific revolution was around 500 years ago, right? So remember, when we think about why don't people just listen to science, the scientific thinking kind of sits on top of all of this thinking that we've been developing for a very long time. All right. So give you, for example, right? It was only in 1860 when Pasteur's experiments, showed that boiling water was really important for to not get sick from drinking liquids, right? So if you think about, but lots of people today, even though this is around 160, you see actually recently there's been an uptick on things like non-pasteurized juice, right? Everyone thinks it's like going to be healthier and more organic and better to drink non-pasteurized juice, and people don't really necessarily even know what that's doing, right? So, but also this is a newer idea. But if you tell people, oh yeah, we have to boil this thing because there's tiny organisms you can't see that will make you sick, that in a way sounds just as crazy as it's like a conspiracy theory or demons or ghosts or whatever else, right? So there's a lot of a lot of these scientific notions are pretty counterintuitive, right? Given how we actually form our thoughts. So one quick example, I'll continue to explain, but a lot of scientific ideas, the whole point is that a lot of ideas in science are very sort of unnatural to how we've sort of evolved to think about things. I'll give you, so talking into, all right, so if you ask someone, how does a toilet work? Or how does a car work? Do you know how a toilet works? You ask people this, lots of people go, yeah, I know how it works. I use a toilet every day and nothing bad happens. It's fine, I know how it works, okay? Then you ask, well, okay, well, explain how it works. Then what happens is that people go, oh, well, you hit the flush and then the water goes away, right? So you have a sense that, or same thing with the car, how a car works? Yeah, I know how the car works. All right. Then, however, you get then people go, okay, well, how does it work? Like, well, you turn the key and then you can steer, right? And so then you sort of ask people and they sort of so people have a sense, they know how these things work, okay? But but you kind of lose that sense once you actually try to explain it. And one of the reasons that what these explanations show is that our explanations often are very superficial, that they're based on just our use of these things, okay? So we know how these things we kind of can say, oh yeah, there's there's something ignites the fuel and it makes the pumps go or whatever, right? But this idea that we all feel like, because when we successfully interact with objects to achieve our goals, we get a feeling like we understand what's happening. Not only that, because we know someone else understands how it works, right? Someone knows how a car works, or you couldn't build a car, right? So the fact that we're part of a group where someone understands how a car works and we can successfully use the car, people get the feeling like they know how it works. Now, this is called the illusion of explanatory depth, where we all walk around thinking like we understand how things work when we really don't. All right. Now, this ends up being important for certain types of misinformation campaigns. I'll give one example. What's my slide I'm going? So a recent study looks at attitudes towards genetically modified foods. And a lot of people are really opposed to genetically modified foods, right? And one of the things that they think, oh, it's going to be really bad for you, right? Genetically modified food is somehow going to take away the nutrients and add in toxins and these types of ideas. All right. So one of the things, so this study, what they showed is they sort of asked people, a lot of people they asked people, well, what are your attitudes about GMOs and food? And then also, how well do you understand genes? Like, and then give them a test of their understanding of genes, like something like you would have on a high school or year one intro biology class, where you have to just sort of define what a gene is. Okay. Now, one of the things they showed is that the people who had the strongest opposition to GMOs and food were the people who knew who couldn't give a definition of a gene, but also were extremely confident in their understanding of genes, right? So the opposition to GMOs was rooted entirely in a kind of overconfidence in their own understanding, right? So now the problem is that people, like I was just saying about the illusion of explanatory depth with things like cars and toilets and all these things, is that people, you just kind of feel, we all kind of have a sense, because we come up with explanations for all kinds of things all the time, that we understand things. Because it wouldn't really work to walk around really being aware of how little we understand. That wouldn't really be like, it'd be very hard to be motivated to sort of walk around with a sound mind. So it's sort of adaptive for us to feel like we understand things, but it can go really wrong. For example, when we're really overconfident and then in our understanding, then oppose things when we really don't know what we're talking about. All right. So, right, it's because we act in the world, when results, we often think what we mean to understand it. But we all actually understand very little. Okay, so let's even talk about, your professors or whatever, right? All of your professors you'll have at uni, they know their area of science incredibly well, right? And they know the thing they research incredibly well. But once you go outside of your area, it's surprising how shallow all our knowledge actually becomes, right? So, when we all kind of, when we're thinking about the pandemic, sure, I can say, oh yeah, I generally get how viruses work, right? I generally get it, but you start digging down a little bit, you wouldn't have to dig very deep before I got to the limits of my knowledge, right? So, but we also all know that someone else understands stuff. Again, so a big part of what humans adaptiveness is that we are sort of happy for other people to know different things and all work together, right? Think about when someone builds even something like building a house, right? The one person does the plumbing, another person does the electricity, another person gets the building materials, et cetera. We all know these different things. And very rarely does any one person know everything about a whole thing, right? But again, we all sort of feel like we do. Being a part of the community that has knowledge in it can actually mislead us to thinking that we have that knowledge. People have done a bunch of experiments where we even told people that, oh, these other people discovered this thing. And then even though they didn't even tell them what that was, those people, if you heard that some other discovery was made by somebody else, you might become more confident in your understanding of it because you kind of know that someone in my group understands it. Now, we'll focus on solutions a bit later, but I'll focus more on solutions later, but a quick preview is to always, of one of the important solutions about this particularly, is to sort of always doubt your own level of your knowledge by trying to explain something to yourself or to someone else. This is really good for all of your stuff. This is also good as a study tool. Your sort of general life recommendation and studying is don't just rely on a sense of it feels like you understand something, really try to explain something to yourself or somebody else. And then then that will really point out to you where the gaps in your knowledge are. And if you have time, if it's for an exam, then you definitely go read about it. And if it's just something else that you're interested in, and you have time, we can go read about it. We can't do this with everything, but when you can always try to increase your knowledge. All right, so another aspect of our explanation. So sometimes they're shallow. Sometimes they're just things that we know very little about. Okay. Other times our explanations are kind of rich, but they're rich of kind of the wrong stuff. And particularly it's based on sort of either cultural histories or our sort of feeling, what it feels like to be in the world. Okay. So the stuff that you see problem 1, problem 2, problem 3, these are studies where in the studies of what we call the sort of intuitive physics, where you say, oh, there's going to be a ball. Let's say those are tubes and there's a ball going through the tubes. And you ask people, which direction do you think the ball is going to go in? Right. And it turns out people's intuitive reasoning is very similar to like medieval impetus theory. Okay. And so this is one of the reasons why when you're learning physics, it's really difficult so you say you're learning about Newtonian mechanics, right? One of the reasons why that's so hard is because it feels so counterintuitive to how we move around the world, right? We sort of basically, when we move around the world, we lift up objects, we try to move them around. We have an intuitive sense of what forces are from that, right? And when Newtonian mechanics, you have to, it doesn't match what it feels like. Okay. And so there's an example from this movie. Maybe this movie is now an outdated reference, but there was this movie, maybe it's 15 years ago, called like Mr. and Mrs. Smith, where Brad Pitt and Angelina Jolie they shoot a gun and move their hand while they're shooting the gun, and they make the bullets bend in the air. Right now, this is not possible, right? But it sort of feels like that's possible in this type of similar to medieval physics. Now, because it feels like we can sort of impart this type of force onto objects when we're moving from them, but this is not true. However, these ideas are really salient in our minds and hit up against the science. I'll give you another example. So here, there's one of the things that's been a sort of folk belief for a very long time is, we go out, everyone always says that, say these things like, oh, people tell you put on a coat, you'll get sick if you're out in the cold, right? This is kind of a thing that people always said. And then let's say one day you realize, but people at one point might tell you that's not actually really true. The reason why people get sick more in the winter is because you're spending more time inside and it's easier to transmit the virus inside and things like this, right? One of the things that people do is this thing called, this phrase up there called explanatory coexistence. Explanatory coexistence, as in we often will blend what our kind of folk belief is, our kind of everyday human, cultural explanation, that say being cold makes you catch a cold, okay? And you might sort of integrate that with the scientific thing like the virus. So one of the things that I sort of realized I had done, I was sort of like, oh, well, maybe being cold makes your immune system more susceptible to the virus. And I just kind of had made that up, because we don't get rid of we tend to not to get rid of these other kinds of beliefs. We tend to, integrate them with the science, right? So this was actually really discovered in this interesting study by Christine Laguerre, where they were looking in 15 years ago or so in South Africa, in these very rural areas where there was an HIV epidemic, but there was very little science education. And there was this belief that witchcraft was the cause of HIV and AIDS. And what happened after there was science education is it didn't replace that belief. It just kind of integrated the two, where people thought, oh, well, you get HIV, it's a sexually transmitted disease, but then someone would say, well, you'd only be able to be attracted to someone who was infected because of witchcraft, right? So this, because the idea is that science doesn't replace, and this is very similar to, where the science doesn't necessarily replace the pre-scientific idea. The people end up blending them together in their minds, all right? Now, I do have to say that it turns out there was a study from 2015 which suggests that perhaps the folk belief about being more susceptible to cold in the cold might actually be somewhat true. But that study came out in 2015 where in mice, and it's quite possible that but all the people who believe this for a very long time, it wasn't because the study existed. All right, so that might just be a little bit of a coincidence. All right, so now going back to this kind of breakdown. Another important thing to sort of remember about what I sort of mean by these concepts that we all have is that so there's notion of a kind of folk ontology. Okay, so ontology is like the categories of things that like exist and how we break them up. All right, so let's imagine, that we think there's the whole universe, and we might bring it up into, well, there's things, there's events, there's mental states, right? And these are all different things from each other, right? So and within the things, there are objects, there are substances. Within substances, there are fluids, right? Within objects, you have artifacts, you have animals, right? Then within the mental states, there are ideas, emotions. These are all different kinds of mental states. So we kind of in our head have something like this, where our understanding of the world is sort of broken up into these types of concepts. All right. And there's a lot of sort of work with a bunch of evidence where we all kind of divide the world up into this way. And often when people seem to be endorsing things that there's no real evidence from, various types of sort of medical practices say, well, there's not good evidence, things like that, or various types of superstitious or fantastical beliefs, they seem to be crossing streams here, where they're sort of crossing, something from one kind of thing to another kind of thing. All right, so let's say we ask someone, do you agree with this statement, either metaphorically or literally? Because metaphorically, everyone can kind of agree with this statement, right? Plants desire sunlight. The furniture in an old house has memories of past inhabitants. Thoughts are contaminated by jealousy. Okay, now, so when you can sort of get sort of the figurative nature of these things, but a lot of people also say, no, these are literally true statements. Okay, now, if these are literally true statements, literal agreement predicts acceptance in all kinds of sort of things that there isn't evidence, and scientific evidence for. And the idea is that this is sort of confusing different parts of this ontology, right? So for example, desire, right, is about a mental state. And we're kind of applying mental states, something like a plant, where doesn't have, we tend to think plants don't have mental states, right? But desire is applying that. Same thing with the furniture in the old house has memories, right? Furniture can't really have memories. There's a sort of, in what we would scientifically say, and thoughts and contamination, for example, is a type of thing that applies to substances, but not to mental states, right? So this type of mixing and matching of ontologies seems to be very predictive of, people who sort of agree with this are more likely to endorse various types of, like energy healing and these other types of things, right? Homeopathic medicine, which doesn't actually have a strong evidence base, right? So, but again, this is all kind of very natural in a certain sense of our this type of stuff just comes out of how we conceive of the world. Now, relevant for this crowd particularly, what this whole thing about is that the misconceptions and the right ideas can coexist in our minds at the same time. There's nothing that actually stops us from doing that. You think it might, but just as I was saying with the witchcraft example from South Africa, this was looking at year 11 and 12 physics students. And this looked at sort of misconceptions of energy. So statements like energy can have a certain color, energy can be sensed as an experience, versus scientifically consistent statements, energy can manifest as electric current, right? Now, things that was interesting here is that there was basically no correlation between how many of the science consistent statements students sort of endorsed as accurate and the misconceptions. Not only that, it was the misconceptions that was predictive of things like endorsing of medical practices that don't have scientific evidence for them. Okay, so and so what thing, but the science, because having more consistent science endorsements doesn't actually have an effect on that, right? So it's sort of like the misconceptions about energy and the accurate conceptions of energy just coexist in the mind at the same time, and it's the number of misconceptions that predict these other types of beliefs about the world. Now, one of the things and what people have been working on in the educational perspective is, well, how do you have to? This sort of shows that if you don't confront the misconceptions, they'll stay prevalent, right? You can't just teach the truth. You have to also try to confront these these misunderstandings. All right. So there's also now evidence. However, you might think, oh, okay, well, those are high school students. What about the professors? Okay. Now, there's evidence that I'll get to that shortly. That these naive types of systems of belief affect even experts. All right. So here's a dialogue from so Piaget. It was a very sort of very important in founding of the field of developmental psychology. He sort of interviewed kids and sort of figured out how kids thought. He was really the sort of founder of that field. So one of the things he talked about was that kids would equate life basically on motion, okay, or some type of self-driven capacity. So he asked the child, "Is a cat alive?" Yes. How about a snail? Yes. How about a table? No. What? And he asked, "Why not?" Well, it can't move. Is a bicycle alive? Yes, the bicycle's alive because it moves. Is a cloud? Is water? Yeah. So, so a lot of kids in this, you might say a tree, and they go, "No, a tree is not alive. It doesn't move." Right. So they might be more likely to say a moving inanimate object, right, is alive, while plants, because they don't appear to move on their own, are not. Right. And so obviously, this type of conception of life is not consistent with the science. And you have to sort of, shift your thinking in school at some point, right? Now, one of the things that was this study was looking at was whether or not mature, adults, even experts, still show some kind of root in their mind. There's something in their mind that sort of reflects this childlike conception of life, right? And the way they did that is by making people answer questions extremely quickly. Because the idea is that if you didn't give them time to really think it through, but make them answer as soon as possible, you could see whether or not there was still an influence from those concepts. All right. So they did it with two studies with undergrads, but also biology professor from Yale University and Johns Hopkins University. Right. These are two of the best universities. Not as good as Sydney, of course, but but up there, right? So, but these biology professors, right? So the study was, you just flashed words on the screen, and they had to, as quickly as possible, just judge, is this alive or not alive? So like a wallaby, a pine tree, a river, a broom, and you'd go wallaby, alive, right? So, of course, and the point is that even biology professors, under these, when they were trying to do this as quickly as possible, were slightly slower to say a pine tree was alive than a wallaby, or to say that a river wasn't alive compared to saying a broom wasn't alive, right? And so the idea is that these sort of childlike conceptions never really leave your mind. They're kind of back there somewhere, even when you are an expert scientist and you walk around the world, all these sort of thinking in this more sophisticated way. Now, Also, it's worth noting that lots of us use our old conceptions all the time, okay? Lots of us, even when we know they're not really true. So for example, I remember I was on a flight from Chicago to Tokyo, and we were going over the North Pole, and I was like, what are we doing over the North Pole? Right? Then I remembered, oh, right, So even though I would never say I'm a flat earther, okay, you still actually, when you often think about moving around the world, we still tend to think this way. We don't really think when we're thinking about our navigation. We don't actually think, unless you're planning a flight, you don't really think about it that way, right? And so, we still often think in the way that's useful to us. And we often think in the ways that we feel, that way that makes sense about the world, the way the world looks like, the types of things that we thought when we were kids. These are all sort of with us all the time. And you don't just get rid of them because you learn the science, right? That's so let's put some of these things together. Okay, we're often quite confident in our explanatory knowledge. But our intuitive explanation, so we're often quite confident in our explanatory knowledge, but our intuitive explanations are often superficial and or riddled with naive childhood conceptions or ontologies. So we often believe things that just piece together science-sounding things, for example. So getting to some more examples of like the types of things that people might just believe after they hear it. So there were a bunch of, I think, police officers in London who all endorsed this notion that the moon affects crime, because of like similar to how the moon, different phases of the moon has different crime rates. And this is related to, for example, will the moon gravity affect the tides? We're mostly water, so we're probably moved by the moon as well, right? Now there's all kinds of reasons why that's not true, but but it kind of pieces sciencey things together. Also, so then you just hear. So let's say you hear. So there's the argument, there's the people, the anti-vaxxers, who think vaccines might cause autism, okay? Right? They've actually constructed a scientific explanation for this. Vaccines affects the microbiome. I don't know if you guys ever talked about that, but there's a bunch of bacteria in our stomach, basically, and actually a lot of the chemicals for our brain, our neurotransmitters, are actually come from our microbiome. So there's explanation that the vaccines are bad for your microbiome, which then changes your neurotransmitters, which then leads to autism. Now, this is piecing together a whole lot of, there are little sort of bits of this that are okay, but they're pieced together in this way. And then it just feels okay to us, right? It sort of feels good enough to people to kind of buy the explanation, because we're all kind of don't really interrogate how superficial often our thinking about these kinds of things are. Now, right, so another sort of problem is, once with our memories and our reasoning, once you hear it, it kind of sticks, okay? So let's say you just say, hey, look at this. This oil is gonna cure your headaches, right? Once you just kind of hear that thing, even when you later hear it's not true, it just kind of sticks in your mind anyway. It kind of feels reasonable enough, and there you go. So you might see a post online about, I had my headaches cured with this oil. It's because it activates my blah, blah, blah in my brain, and now I'm fine. It just kind of feels good, people go with it. Now, sometimes it's true that there was never evidences, but this is actually important about how we kind of stick to whatever we hear. We stick with it. This is true even when it appears to be science-based in the first place, all right? So there's a study published in the very prestigious journal Nature in 1999, which made the claim that night lights in children's rooms and bedrooms when they were little kids caused nearsightedness, all right? Now, there was a correlation, even though we all can say the words, correlation does not mean causation, doesn't actually stop scientists from doing this all the time. So the scientists concluded, correlation to causation here, where they go, the night lights were giving people, night lights, being exposed to night lights when you were like a baby or whatever was leading to this nearsightedness, during adolescence. Okay. Now, one of the things that they didn't control for initially in this study was parents with glasses were more likely to put a nightlight into their kid's room. All right. So what actually was happening here was was that people who wear glasses are more likely to have kids who need to wear glasses from purely genetic reasons, and the nightlights didn't have anything to do with it. right? But the problem is once this idea kind of gets out there and it sounds good, we tend to stick with it. Now, this is a good example of this. I've never seen an example so good than this past pandemic. All right. What came out when the pandemic started, everyone was focused on how it spread from droplets on surfaces, right? So everyone's wiping down every surface. People are cleaning their groceries that are delivered to them, right? People, and no one's wearing masks, right? No one was worried about that. So at first, everyone was thinking it's all about, it's all about surfaces, wiping, cleaning everything. All right. But really by June of 2020, the science was already making it much more clear that actually airborne transmission it's really much more about airborne transmission than it is about surfaces. All right. So we've sort of known that now for like over a year, that the surface thing isn't really true, right? And of course, everyone was doing the best they could. The data, the scientists are just communicating what they know at the time, and evidence changes, right? But the problem is that society took a very long time to shift with this change in the evidence, right? So for example, this is an article from May 2021, where basically where the Australian building standards are, people are calling to change building standards to allow better ventilation, so there isn't as much inside transmission. And the Australian standards have replied with, that's not how it spreads. It spreads on droplets on surfaces, so we don't have to change our building standards, right? So, so now it's what the sort of lab experiment shows. Now, what the experiment shows, you can't really do this in the real world, but you can do this with things in your psych lab. So you can show that everyone would be fine with the other explanation if it came first. It's just kind of like whatever explanation gets there first sticks, and it's really hard to change it in people's minds. But it could have been the other one, right? It could have. So if it turned out everyone was saying air-based transmission from the beginning, we might be in a very different place now, right? And I'm not. Also, just recently here, right? This is relevant because for the current lockdowns where there's very, very little outdoor air-based transmission, right? And so you can sort of argue whether or not that needs to be part of, whether, how much limiting outdoor activity needs to be part of it, given how little there is. But, anyway, that's another story. So, all right. So what can be done about all of this? And sorry, So I'm mainly pointing out all these problems, how easy it is to fall for these things. All right. So what can be done? But also I'm going to talk to you about a few more problems shortly as well. Don't worry, we're not out. So there's some work. Let's say you come across some information online. So maybe not maybe not that type of example where it really was rooted in the evidence at some point, but let's say you come across some misinformation, some just sort of made up science claim online. Now, there's some work that suggests just sort of nudging people to stop and think, be like, why don't you just think for a second about this? This actually does help some of it. So sometimes something as simple as this, hey, just stop and think about this for a second. Some people sharing beliefs and some people's spreading of misinformation can be stopped that simply. But that's not all of it. There's just some of it. Because sometimes you see something and it's just such a crazy claim. It's kind of exciting to see it, and it makes intuitive sense that you share it without thinking about it, right? So even just nudging people to think about things before they retweet or whatever does have some effect. However, sometimes you have to go further than that. All right. So a theory first come up with in the 70s was, you can tell this is a picture from the book from the 70s, was this idea that you could inoculate people against bad ideas or misinformation. Now, the idea was that similar to like an actual vaccine, is that you would sort of give them a kind of weaker version of the argument. So you want to be so the important thing has to be before they're exposed to the misinformation, right? Because once you get misinformation, it really sticks. So people are thinking, okay, what if it's before you expose the misinformation? You warning that this threat's coming, like a misinformation threat's coming. You talk about the motivation that someone might have to deceive you, then you kind of you kind of present their case a little bit and then refute it with a counter explanation. And if you do that before the misinformation gets there, then that can be effective. Oh, so I'll give you a recent example. There was so then in 2016, there was a petition that was spreading online that said tens of thousands of scientists had declared global warming a hoax. And there was evidence that the people who saw this survey, and this was asking for people to sort of sign on, and this was actually, it was asking people basically with science, any kind of science degree, to sign this, okay? And there was sign that people who were exposed to this survey, it affected their opinion. However, then some psychologists did an experiment where people who hadn't been exposed to it yet, they said, okay, they forewarned them that politically motivated groups use misleading tactics to try to convince the public there's a lot of disagreement between scientists. They go, the scientists don't all agree in global warming. We don't have to, we don't have to change any of our laws or behaviors or policies. Right. So he's going to say, okay, politically motivated groups like people who make money from fossil fuels, things like that, are going to convince the public a lot of disagreement. Then for the preemptive refutation, they point out, hey, so actually, if you looked at the signatories of this petition, some were clearly fake. For example, Charles Darwin was one of the signatories. Okay, and then also it had 31,000 people on it, but then they pointed out, well, that's only 0.3% of people with science degrees, right? So this was sort of calling scientists, like anyone with a science degree, not necessarily a climate scientist, right? So these weren't people with like PhDs in climate science who'd spent their life researching the climate. This was just kind of anyone with any kind of science degree, and a lot of them weren't even real people, right? So, and then also you can inoculate people, including, well, actually 97% of climate scientists have concluded that human-caused global warming is happening. All right, so this experiment, this psych experiment, was effective. And it was a similar result with anti-vaccine conspiracies, where they sort of showed people either before they sort of showed people the counter message even before they read the kind of conspiracy theory about how vaccines are hurting people and all these other kinds of things. And seeing it beforehand was more effective than refuting the conspiracy theory afterwards. So being warned and getting so really what the order of these things really matter. So another challenge here. Okay, so I'm finally gonna get back into that whole group discussion. At the beginning, I talked a lot about the group, this notion of group identities and our memberships to groups. And Daniel Kahan has done a lot of work on how group identity and the values that your group holds, really how this affects thinking. And all right, so we showed this to people. All right, here's a table, and it's describing a made-up experiment of people who use skin creams to get rid of their rash. All right, so you had people who used the new skin cream and people who didn't use the new skin cream, and then you saw who people with rash got worse and people with rash got better. All right, so now to think about whether or not the skin cream is effective, right, you should go, okay, well, does the percentage of people who got better higher when they use the skin cream or not didn't use the skin cream? All right, now, right, so 223 divided by 223 plus 75, it's actually less than 107, so here in this table, actually having less, the non-users of the non-users of new skin cream actually had a higher proportion of recovery. So that would suggest this skin cream didn't actually do anything, okay? Now, however, when they looked at that, you sort of looked at people's ability to sort of figure this out and assess their basic numerical thinking, okay? So now, when people's basic numerical thinking predicted, right, the people who were sort of better at thinking numerically were better at sort of saying the correct thing about this table, and people who weren't as good numerically thinking weren't as good at finding that conclusion, all right? Now, however, Then he had a different condition of experiment where some people saw this about rash and skin cream. Other people saw the exact same numbers. This is in the United States, but I made it about gun control laws and then gun control laws and violence and like crime and violent crime in cities. Okay. And then suddenly, then it didn't matter how good anyone was at math, at their ability to figure out whether or not the gun control laws were effective in reducing gun violence. What mattered was their political affiliation, right? So people who were, people who supported in their core values, people who support right-wing parties in America are very against gun control laws. They have the general value of individual freedoms over public health, right? And so suddenly when it was exact same numbers, the gun control, whether or not your political views is what predicted your ability to evaluate the numbers properly. And it didn't actually matter how good you were at sort of thinking mathematically, right? So the idea is that the gun control laws is this highly politicized issue. And so and that kind of takes over their mind, and it's they're no longer sort of thinking just numerically if it's something about rash and skin cream, because no one really cares about that in the same way. All right. So now there's some evidence to deal with this situation because our group identities and the values of those groups seem to really be in charge, really sort of take over how we think about things sometimes. Sometimes what you have to do is reframe your message to be about the value of that group, right? So a classic example of this is sort of, when you're focused on renewable energy, let's say if you want to shift away from coal and shift towards solar and wind and things like this, you can sort of talk about, well, this is actually really good for the economy. I mean, lots of new jobs, right? And you can kind of ignore the climate effects, because the jobs and the economy is often what the people care about who are kind of against acting on climate change, right? And there's some evidence that this type of switch of messaging, where you're sort of, instead of trying to focusing on what you might view as the most important evidence, reframing it to be about the kind of value that another group shares might make it more effective. Now, currently, this is starting to work in the population as a whole, but our current political leaders are still not convinced. So there's more work to do there, but this type of reframing can be quite effective in some cases. Now, I think we're getting towards the end of it. So I just want to just quickly highlight some of the work I've been doing around the pandemic, where you saw that lots of people, this wasn't as true here, right? But in the US, you might have seen online that you'd have these people protesting businesses being closed and having to wear masks. They're smashing down the windows of a Starbucks to get coffee because it's closed, and they're saying this whole thing is a hoax. Right. So one of the things that my sort of work has shown is that when they're saying these things like a hoax and these things don't work, they actually don't mean it literally. One of the things show that they actually do understand that there is a real threat to health, and that lockdowns are potentially effective for preventing the spread of the virus, but they actually just don't care as much. So they often use the language to say, we don't believe this is happening, but with some research, we sort of uncovered that they actually just care about their individual freedom to go get a coffee more than the public health. And it's about their morals, not actually about their literal thinking. Anyway, so that's not really the, luckily Australia has not had that same type of reaction that America did. All right. But often, but this their group, but this was really correlated with group identity. Right. And right now in the US, if you look at vaccination rates in the US, where they've had vaccines available for longer than us, it's almost perfectly correlated where vaccination rates with political party affiliation, or people who voted for Trump haven't gotten vaccines, and you vote for Biden, you did get a vaccine. The correlation is incredibly strong right now. All right. So sorry, this is a bit of a downer note, but a final warning. right? So sometimes, sometimes misinformation is somewhat benign, like, oh, this herbal medicine will cure your headache, right? And then you're like, oh, that doesn't seem like that big a deal. If you believe that, maybe you just waste some money, though there is some potential health problems. But other times there's really a history of science of people using pseudoscience, what it appears to be science, to justify really horrible things. I won't go too far into this. There's one example in America. There were these laws. These are now older laws, like, not letting Asian immigrants join certain types of workforces. And there was this idea that a rice-based diet would sort of make you not as strong, right? And so they sort of had this sciencey sounding explanation as justification for this, because people don't just say, we don't like this group of people, let's not let them do this, right? You often have to use something science sounding to justify these types of things. I'm gonna go into it, but that's also minor to his history of eugenics. But even these types of ideas, you might think these are old ideas, but psychology and biology, some of these ideas are still actually around. Anyway, so just something important to think about when we think about science and misinformation is how, we sort of think of, scientists tend to think of science as this sort of, force for good and truth, but it can, people can make something sound sciencey to justify very the worst types of things. Right. All right. So as my final point before we get to have questions. All right. So I'm going to summarize all the recommendations for what we can do about this. All right. We all have to trust others. All right. So we all have to trust others, right? At a certain degree. There's not enough time to know everything, right? No one can know everything. So there's only so much we have so much we can do. But if you come across some piece of information that sounds fine at first blush, just do a quick sense with yourself. First, before you share it or tell someone else, just do a quick sense check. Is this actually reasonable? Could this be fabricated? Is this really can I just double check the source real quick, right? So just giving yourself a quick sense check can be quite helpful. And really be rigorous about your own beliefs whenever you can. Try to explain things to yourself and identify what you don't know, right? So think about, you always, in your studies and in life, always try to, because we often feel like we know things when we don't. And so you can't just trust your feeling that you know something. So be aware, of what can make us feel confident, right? So our own naive conceptions, or knowing that other people know something. Be especially wary when evaluating potential counter evidence to a belief that's part of your group identity. It can be very hard for any of us, if we have a belief that's part of our identity, to show the counter evidence for it. Okay, but can you do how it's keeping yourself biased? Because one of the things I'm saying about this about yourself is sometimes people think about conspiracy theorists and they'll tell you, oh, we're really skeptical. Conspiracy theorists are often super skeptical of other people, right? They go, you can't trust the government or whatever, but they're not skeptical in their own beliefs, right? They're not skeptical in their own understanding of the conspiracy that they're endorsing, right? So it's really important to sort of be skeptical about your own level of understanding, right? All right, but trying to help others. Let's say you're trying to help others. Well, they're saying inoculation may be better than trying to debunk later, right? If you see something going around online or something like that, and you can tell it's not true, now on the one hand, you don't want to just spread it further, right? By trying to inoculate. You don't want to just show it to everyone and go, hey, don't look at this. Then you might be incidentally spreading it places it wouldn't go. But if you sort of know anyone who's going to be vulnerable potentially to be persuaded by this type of thing, you have a family member or a friend, you can try to reach them before it does, and try to talk about what's wrong with it, right? And again, and trying to appeal to existing values whenever you can of the other people. How can you frame whatever the truth is to align it with the things that those people care about? But one of the sort of challenges that social sciences are dealing with is that when data conflicts with your values and your social identity, usually it's an unfair fight and the data loses, unfortunately. This is just something that's true about humans, right? But this is what myself and many other social scientists are researching. is how to kind of how to win this fight. But yeah, anyway. So anyway, I think that's everything. If any of you guys are interested in in reading more books about this type of topic, The Knowledge Illusion and Science Blind are both books that I talked some of the stuff in this book. Range is more positive, but this book Range is more about how do we kind of make people the best thinkers? How do you kind of make people as good as thinkers as possible? And it's a popular audience book, but it's really good scholarly work. All right, that is everything. So I guess I'll look.
Yeah, we have some time for some questions.
And great.
We've got loads of questions.
Oh, good. Yeah, sorry if I went too long.
No, that's okay. Okay. That's okay. There's a lot to think about there. So why don't I call on a few people to come and ask their questions themselves, actually. Where we might start, let's see. There was a good one up here somewhere. I thought we might start with like Audrey. Audrey, you asked a question earlier about the public's understanding of science. Do you want to come and ask your question? Audrey, let's see if we can get you on the spotlight.
I'm really sorry, I've melted into my background.
You're looking good, I gotta say. Just go with it. Just go with it, Audrey.
Thank you for the lecture. It was really interesting, really eye-opening, and it was really enjoyable. My question was, do you think the manner in which we tend to apply human concepts to a large amount of aspects in our life, you gave the example of how plants desire sunlight, hinders like the general public's understanding of science and how we perceive it?
Yeah, 100%. We definitely apply human things to things that aren't really human, and when I was talking, and kids do it even more so, right? So I was talking about that developmental trajectory where if you ask a kid sometimes, why are the stars bright? And they might go, oh, because the stars are happy, right? So that's something that we probably wouldn't do as adults, but a lot of our thinking is rooted in this. Often we reason in human-centric ways, right? Now there is some evidence that there's cross-cultural differences in this, and sort of contemporary Westerners are particularly likely to sort of reason about everything in human-centric terms. But yeah, 100%. Totally. I mean, the energy example, right? Yeah, all these examples where people really we're kind of misattribute 100%. We're misattributing ourselves to the world. Yeah, I mean, so it's hard to, but encountering that is an interesting thing as well. But it's also so hard to not. You want to make things appealing to people as well, and so when using that kind of language, it is a kind of more appealing way to describe things too, right? And that's often the challenge, I think, with some of these communication aspects, is how do you kind of make this more appealing and relatable while still maintaining that type of accuracy?
Thank you.
No worries. Yeah, thanks for the question.
Thanks, Audrey. And actually, Audrey asked another question, but I'm going to lump it in with a few other ones in here as well to sort of try to summarize a bunch of different lines of thought here, which is around social media being such a vector for information and misinformation at the moment. From your work and also I guess your professional opinion, is there something that could or should be done around social media in order to try to limit its incredible influence over people's opinions and ability to spread those opinions when those opinions are just frankly bad and wrong? You got any thoughts on that?
Yeah, it's one of the big. I mean, it's certainly at the center of all this discussion, right? Because on the one hand, right, one of the problems is that the social media platforms, there are these private companies, right? And so when people say, well, how should we deal with that? Well, sometimes people just want the private companies to do it themselves. You go, okay, Facebook, you just stop letting people share this stuff. But then the issue becomes, wait, so now we have this private entity regulating all of these aspects, right? When, and then they're picking and choosing, why should they be the arbiters of that, right? Because I mean, now I'm forgetting this example, but I think there was this example, I remember seeing this example where someone was was talking about how like tech companies were actually hurting working people and things like that. And it was kind of flagged on Facebook as this kind of source of misinformation, right? Because it was against the interests of Facebook for this to be shared, right? But it wasn't necessarily actually misinformation, right? And so, and so from a, I mean, my expertise is not in the business side of these things, but you could imagine how, because of the, but then if you say, okay, well, does that mean we should have government regulators in there figuring it out? How that would work is really complicated, right? And so it's certainly 100% the case that the social media platforms, because it's connected, it's sort of accelerating a share of some of this information in a way that, because people have always, sold snake oil, right? This has always been around, right? But social media appears to be accelerating everything and actually figuring out what it's really not from a sort of policy standpoint. It's, there's a lot of debate. Everyone sort of recognizes the problem, but there's a lot of debate around how you actually should do anything about it. I mean, I actually have a student who's designing who's in human-computer interaction, who's designing an interface that just starts automatically tagging when somebody's been retracted, right? So you can just see, like, okay, because when you have so let's say you have so for example, the famous autism and vaccines paper was retracted, right? So it was published and then retracted. But then there's a news story that talks about that thing, and the news story doesn't ever actually refer to it being retracted, right? And so, or later, let's say it gets retracted, then does someone at CNN.com go and update their old post about it to point out this is actually a problem, right? And so there's some things where, like, this student who's working on it, who's trying to figure out ways to get that to, that's one small piece of the problem, just sort of how to alert people that something was retracted, and then how to get anyone to care about it. Because it can even sit there in the screen, doesn't mean that anyone's going to pay attention to it either. Right? Yeah.
So and that's just one part, that's one small part of the whole problem. And even that's almost intractable. It's such a huge problem. Yeah, we can all identify where the general area of this issue is, but what the hell do you do? I mean, putting it over to governments to try to regulate. Governments don't even understand the technology, let alone how to regulate it. Look, let's leave that one. Push that. The next one I'd like to call on is Sophia. One of the early questions we had was from Sophia about childlike conception. Sophia, would you like to come and ask your question?
Yes, but first of all, I just really quickly want to say thank you so much for this talk. I think I'm going to leave it doubting like every thought I've ever had.
But you don't want that. You don't want to go too far. Yeah.
But doubting your thoughts is a good thing, Sophia. That's fine.
Yeah. Sorry, I should have said that you could go too far with that. But yeah.
Moderation, I guess. But my question was, how you were talking about like childlike conceptions that we still believe in, even though we know like what's right. Like, why don't those conceptions leave us?
Oh, right. Why do they stick around forever? Right. I mean, there's something about, because they're so, well, there's a few things. So they're so useful for us, right? Because we never, when we're building up these concepts of the world, they're sort of directing how we move around and interact with everything, right? And because they keep on kind of being useful, right? So that's why I sort of gave the example of the sort of 2D map navigation, right? We kind of think about the world as if it's flat, even if we know it's not, right? Because when we're kind of navigating around, if you're getting in your car and driving somewhere, the fact that the world is spherical doesn't really come into play, right? And so with that type of example, we're just kind of thinking about the world in terms of what's helping us, be in it, right? And because they continue to have sort of uses, it gets really just deeply reinforced. And so for whatever, you can't just reach out and get rid of it. I mean, and there's other things that have to do with this thing called kind of source monitoring, where there's a bunch of sort of memory effects where if for example, if you have a newspaper article that's like fact versus myth, right? And it's like, let's say it's about like whatever, headache medicine, and it's like fact does this, myth does this. You ask people a week later, right? And they kind of remember what was in the article. They don't actually remember which were the facts and which were the myths, right? And so it's like the way it's like encoded in your memory, it's just, so the content is kind of, the individual ideas are easier to remember than linking that with, no, that was the not true one. Oh, that was the true one, right? So there's a certain about that just sort of sticks with us. And that's, and that's its own, it's, so that's like there's just something about our brains, right? Where that just, we're much better at taking in information than removing it. Like we can just keep on adding more stuff. But it's hard, but actually saying, oh, that one thing that you remember, never think about that ever again. That just doesn't really, it doesn't really work, unfortunately. Yeah. But we get used to habits of checking ourselves, right? I mean, so when you're a professional biologist, you get in the habit of kind of inhibiting those conceptions, right? You kind of go, okay, well, that's, you get in the habit of ignoring it and thinking another way, but it doesn't mean it's not under there. Does that make sense? Yeah.
Thank you, Sophia. That's a good question. And it actually, what you were just saying there reminds me a little bit of some absolutely classic physics education research, research into how students have conceptions and misconceptions, and what do you do about that? And in physics lecture theatres, it's very standard to have lecture demonstrations. You get up and you show the physical principles with kit up on the front bench, and you show people what's going on. And wonderful research showing that you can get a lecture theatre full of physics students, and you can say, we know that you have these misconceptions, right? You think that this physical idea works this way. I'm going to show you that it's not that. And all the students nod, fantastic. And you show them and they all nod. Yeah, did you get that? Yeah, I did. And they walk out of the room, you give them the test again, and they still have the misconception. They just think that they've been educated. And you've actually got to challenge that belief and get them to commit to sort of questioning their ideas.
No, it's true, and that's why it's such a. That's why it's hard, right? If this is the fundamental thing that's what makes this so hard. One of the things one of the things really interesting about that Science Blind book I was talking about is that it goes through the history. It talks a lot about how like earlier ideas in science, in the history of science, like in medieval times and other kinds of things, are often very much aligned with our current intuitions. So it kind of does this historical analysis and about how, and sort of have an understanding of like why these were the theories that people had before they were then sort of tested and figured out to be different, right? And that makes a lot of sense, right? That these misconceptions that we have would be the basis also of the theories that people were testing when people first testing it, right? Yeah, and that's it's true, right? But how you actually get people to do it?
What do you do with that? Yeah.
It's the hardest.
I think we've got time for. We've got time for one more question, and I think this is an interesting one. So I'm curious to see where this one goes. Tobias, are you out there? You had a question about the placebo effect, and so if you're out there, Tobias, and you want to ask that one, then unmute yourself and come and say hi.
Hello. Thank you for the lecture you just gave. So I have to ask, how do you think the mind and misinformation influence and apply to the placebo effect, and why does this sometimes work to help cure a disease or illness?
Yeah, no, all right, great question. So, one of the colleagues in the School of Psych here, Ben Cullett, we have a person here at Sydney who's an expert in placebo research, Ben Cullett, so you look at things like, homeopathic medicine or something like that doesn't appear to doesn't beat a placebo in an experiment. People do seem to get better. And so there does really seem to be something very much about the expectation. So the expectation of getting better is sometimes a driver. Now it's particular kinds of things that it's good for, right? There's, it doesn't really work for like diabetes, right? You can't just suddenly have, you need insulin, right? There's certain, but things like pain and nausea, these other kinds of things that have this more sort of subjective component to it, show pretty reliable placebo effects. And by setting up people's kind of positive affect and their expectations, there does appear to be that in itself does appear part of it. Now, there's other aspects of it, because sometimes you might have a context. Sometimes it's actually a learning thing, like like how Pavlov's dog type of stuff, where the bell makes them salivate. There's actually some evidence that placebos sometimes work the same way, where if you, so let's say for example, you were getting a pain medication, and you were legitimately getting it, and every time you got it, the same nurse brought it to you, okay? But then let's say after 10 times, they start giving you a fake pain medication, but then it's the same nurse, right? Your body has learned that it's going to get this type of drug, and that gives your body a certain response, right? And so then the nurse is like the bell for Pavlov's dog, where then your body sort of starts producing the things to make you feel less pain, even though you're no longer getting the drug. So that's a situation where that you were at first getting a real drug and then it's taken away. That's not the same thing as, say, a homeopathic or something thing that was never really a real drug. But that seems to be much more about the positive affect you're getting. So, for example, naturopaths and people who sell us type of things are often really, really personable. And so sometimes the effect is just having someone being really nice to you and talking to you, right? Because sometimes Western doctors, whatever we call it, aren't as friendly, right? And they're not as empathic, and they're not as just sitting there making it all about you. And sometimes those are the effects that makes it feel like you're in less pain, less discomfort, and things like that. So, I mean, it's an open question. It's and there's a lot of research on it. And it's not totally explained, right? That's why people are still working on it. But I think that covers a bunch of it, I think.
Thank you.
Yeah, it's such a fascinating area. Thank you, Tobias. So all that we have left to do then is, in the time-honored tradition, we thank our speaker. So could everyone bang your hands together in the usual fashion, throw the thank yous into the chat, and pour out the love through the internets to our wonderful speaker, Micah Goldwater. Thank you so much, Micah. We really appreciate it.
Oh, great.
Luna, if you're still out there, you'd like to come and say thank you on behalf of the ISS.
Yeah, hi, Dr. Goldwater. So yeah, on behalf of all scholars, I'd like to extend our gratitude and thanks. You certainly manipulated us into loving your talk, despite perhaps being left doubting everything we know. And your insights into the world of misinformation have been invaluable. So once again, thank you so much for your time and sharing your knowledge.
Great, thank you so much. Yeah, it was really great talking to you all.
Yeah, really, really good to talk to you and have our brains slightly stirred up and confused, and ultimately I'm sure we'll be better people as a result. Thank you so much again, Micah. We really appreciate it.